Good morning children once again, and in the previous video I said you about moment of forces, all those definitions we have discussed, and then children one question can be asked that why in the hand fodder cutting machines or in the doors the handles are kept at the edges. Why in the hand fodder cutting machines or in the doors the handles are kept at the edges? You will have to say that in the hand cutting fodder machines or in the doors the handles are kept at the edges so that the distance can be made maximum. And when the distance is made maximum, the moment of force is also maximum, and therefore what happens that we have to apply a lesser effort to open or to run the hand fodder cutting machines, to open the door or to run the hand fodder cutting machines. See children, once I want to say that moment of force, this you will write. See, you will have to write the reason that in the hand fodder, if it is not asked hand fodder cutting machine, then don't write the hand fodder cutting machines. If it asks about the door, then only write about the door. If it has asked only about hand fodder cutting machines, then write about the hand fodder cutting machines. Don't write about the door. I'm writing in combination. In the hand fodder cutting machines, the handles are kept at the edges I'm writing, but only door, then only write edge, so that the distance is made maximum which generates the maximum moment of force, and hence we have to apply least effort to run the hand fodder cutting machines or to open or close the door. Open or close the door. But at the same time, you have to write the formula. You will write since moment of force tau is equal to force into perpendicular distance between the line of action of force and axis of rotation. This you will write because a certain moment of force is required to either open the door or close the door, and then either to run the hand fodder cutting machine. There are more examples, children. You can think of a spanner also. Long handles are made. In the hand pipe, you have seen that long handles are made. The reason is same, that if you keep maximum distance, then maximum moment of force is made, and therefore we have to apply this force because a certain moment is required to turn it, and if we keep the perpendicular distance more, then force will be required the least. And then children, next topic, if I come, then it is a couple. What is a couple? Two equal and opposite forces, it cannot be unequal. If the forces are unequal, then it doesn't form a couple. It can turn the body if the line of action are different, but it will not be a couple. So two equal and opposite forces whose lines of you can say a force in which you can write in which lines of action of forces are different form a couple. Children, if I say you that there is a body and I apply here 5 Newton force and 5 Newton force, it doesn't form part. It is, yes, the forces are equal and opposite. The forces are equal and opposite, but here the lines of action are same. It will not form a couple and it cannot turn the body. But if I say that a body is there, lines of action are different. Two equal and opposite forces whose lines of action are different, and children, you can do this way also. So what it will form then? It will try to turn the body. It will always try to turn the body. Couple always try to, has a tendency to turn the body. So two equal and opposite forces whose lines of action are different will be called as, children, you can draw this way also. This also is correct. By two equal and opposite forces, and it will always try to turn the body. You can one upward, one downward, anywhere you can do. This way you can show that it is a couple. And couple, children, any example if you want, then you can give from tactical life also. You can give of the key we one by the thumb we force it upward, and by this we are forcing it downward. Then this way, that way. Then you have seen in the paddle case, bicycle, in the paddle of the bicycle. Then you have seen while we open the bottle, then what we do? By one, we apply force that side, and the other side we apply force this side. Means whichever time you are seeing that two equal and opposite forces with lines of action are different, will be called as they will form a couple. Okay. Now, unit of couple. What is the unit of couple? Same as the moment of force. That is, its unit is Newton meter. If I write in whole, then small letters are used, children. And if I write in short form, then we write like this. Newton is a scientist name, whereas meter is not a scientist name. So that is why it will be always be written in small letters. You know all these things, children. If I talk about the formula, couple is equal to, mathematically we can say, that either force, means if it is 5 Newton will not take 10. Either force, only one will take, this 5 or that 5, into arm of couple. And what is the arm of couple? If I show you, children, this is only the perpendicular distance between the two forces. That is called as arm of couple. Perpendicular distance between the line of action of the two forces. That will be called as, so couple either force into arm of couple. So if I calculate this one, think that if I am calculating this, so what it will be then? 5 into, and this arm of couple is here 10, so it is 50 Newton. And children, remember that moment of force, couple, all are vector quantities. So you will write the direction also. If it is going in this manner, then you will say that it is anti-clockwise, ACW moment, or you can write it equal also, ACW. Now children, if I talk about now, units of couple also done, equilibrium of bodies. Next topic is equilibrium of bodies. Equilibrium of bodies. What is it? Equilibrium of bodies when a number of forces, when I am talking about number of forces, it should be 2 or more than. When a number of forces, 2 or more, acting on a body such that it maintains the state of rest or the state of uniform motion in a straight line, then the body is said to be in equilibrium. When a number of forces, two or more, acting on a body such that it maintains the state of rest or the state of uniform motion in a straight line, then the body is said to be in equilibrium. Equilibrium of bodies, when I am talking about them, there are two types of equilibrium: static equilibrium and dynamic equilibrium. Two types, children. Static equilibrium, I am not rubbing it for a reason. See, there are two types actually: static equilibrium and dynamic equilibrium. You have not to learn. I have not rubbed that mobile. From here only you can get those two. If they are asking you static equilibrium, you will write when a number of forces, two or more, acting on a body such that it remains in the state of rest or it maintains the state of rest. Don't write then uniform motion in a straight line. Don't write, because it is static equilibrium. So when a number of forces, two or more, acting on a body such that it maintains the state of rest, then the body is said to be in static equilibrium. But if I am writing dynamic equilibrium, when a number of forces, two or more, acting on a body such that it remains or maintains the state of uniform motion in a straight line, then the body is said to be in dynamic equilibrium. So from one definition only, to split it into two parts, you are getting two. You have not to learn or try to understand two things in a separate manner. From one definition only, you are getting those two. Now, coming to the principle of moments. Principle of moments, when I am talking about, children, principle of moments. When static equilibrium, you know that, one example I am giving you, children, that if a body is kept on a table, a book is there, kept on a table, then what is there? It is under static equilibrium. Why? Because the gravitational force will be there, its weight will act downward, vertically downwards, and a normal reaction force is there which acts upward. Gravitational force, you can say it as weight also, its weight. So here two or more forces are acting, but the body remains in the state of rest. Dynamic equilibrium, if I talk about such examples, you can think from your practical life, children. See, if I think about that you are going on a bicycle and you are regularly paddling it so that it can move, and you are side by one friend is there and you are regularly paddling, but here the cycle speed is not increasing. You are regularly paddling, your cycle speed not increasing. Why? Because your force is only that much to overcome the friction. If you do not paddle, it will reduce its speed. The cycle, you will see that it is the speed is reduced. But when you paddle, actually you are just overcoming that friction, and the friction is overcome by your paddling and you are going in uniform. That time, dynamic equilibrium is there, because two types of forces, friction and your force is there, but still the cycle is moving with uniform motion in a straight line. So here, children, it is an example of dynamic equilibrium. Children, in this way we are Today we are ending, but again still some of the topics are left in this chapter. Thereafter some numericals are also there. We have to discuss some numericals also of this chapter. But in the next video, bye for